Hi there, this is Penelope, and this is a recorded version of the live class for MG5004 Topic 1 Class 1 on Wednesday the 26th of February. This may actually end up being 2 videos because I'm limited to 15 minutes per video. In maths, we all need to speak the same language, so we need to make sure that we are indeed talking about the same things. So I filled in some of these just before by accident. The integers are negative numbers, 0, and positive numbers. Sometimes you see them written as I, but they are made up of 3 sets, if you like. They're made up of the natural numbers, 1, 2, 3, and so on, and 0, and the opposites of all of the counting numbers. A useful way to think of the integers is to use a number line, an integer number line. The further a number is to the right, the greater it is. So the further to the left, the more negative it is, the smaller it is. We use R, sort of that funny R, to talk about real numbers. And real numbers are a set of 2 smaller sets, the subsets of rational numbers and irrational numbers. And a real number is a number that can be written, as you would think, as the ratio of 2 numbers, say. So a rational number is something like 3/2. And an irrational number that's not. And an irrational number might be something as √2 or pi, because they can't actually be written as fractions. So they are the irrational numbers, and real numbers is the set of all of those. So pretty much any point that you can have on a number line is a real number. When you see all of the numbers together, all of the types of numbers together, you'll see that they all fit nicely together. So there's the natural numbers, the whole numbers, then the integers out to about here. Then those 3 are part of the rational numbers. Then there's the set over here of the irrational numbers. That's the ones that you can't write as a ratio. Together, they all make up real numbers. Now, outside of that is the set of complex numbers. We'll do that later on. You may remember, if you've done the diploma, about complex numbers. They're things where you've got I or J, and we'll deal with them later. Now, some of this may be just absolutely so basic, but the thing is that you need to be able to do it with numbers so that later on we can do it again with algebraic things, and even more so with things like tan and sine and cosine. Now, adding integers, we can show any integer addition or subtraction on a number line, and you would then take the first point as the starting point. The second integer tells you how far to go from the starting point. So this one you would start at -3, and then you would go 8 units to the right, and then you'd end up at 5. Now, I know you can do that in your head, but it's just a good idea to think about it on a number line for later on. So to add a positive, you move right by that amount. To subtract a positive number, then you're going to move left by that amount. Adding a negative number is the same as subtracting a positive number, and you need to get that straight in your head when you have x's and y's and things thrown in as well. Subtracting a negative number is just the same as adding a positive number. So in this case here, the adjacent negative signs cancel each other out, and you have the final answer of 17. Multiplication, think of the rules of multiplication. You know how to do, well, presumably you know how to do them in your head for a lot of them, but multiplication of integers is based on the multiplication of whole numbers. If 2 integers with the same sign are multiplied, then the result is positive. So 4 times 8, that's positive 32, and -5 times -2 is positive 10. So when the signs are the same, there and there, the answer is positive. When the signs are different, the answer is negative. Again, this should be straightforward for you, but it's just a matter of starting again, kicking those brains, and doing everything. The rules for division are the same as the rules for multiplication. So if the signs are the same, then the answer's positive. If the signs are different, then the answers are negative. So however you like to remember it, it's positive, negative, negative, positive. Those are the rules. Division then, same again, as I said, if your signs are the same, the answers are positive. This is a negative one, this is a negative one, and here the signs are positive. So the signs are the same, so the answer is positive. Sometimes it's important to remember the actual rules. Addition is commutative. You can add in either order, so 3 plus 4 is the same as 4 plus 3, but subtraction is not, because 3 minus 4 doesn't equal 4 minus 3. Multiplication is commutative. Sometimes it just helps to be able to do things in a different order. Obviously, division is not commutative. The distributive law means you can distribute multiplication over addition, so that you can expand the brackets whether you've got positive or negative. So this is where the rule that allows us to expand brackets. The associative law of addition, again, it's a grouping thing this time, and it's what allows us to kind of, for this one, for example, it's written as A times B times C, but in actual fact we can do the B times C first without brackets and then multiply by A. Just watch the division by the distributive law of division. It's a little bit trickier, but not much. Division's the bad boy of the lot. Okay, the order of operations, you might have it as bod mass. Oops. We might have it as bed mass. It's really important that the priority starts at the top and goes down. Now, division and multiplication are the same priority. They're the same level in the hierarchy as is addition and subtraction. If you've only got, say, division and multiplication in an example, say 5 divided by 2 divided by 1, well, 10 times 3, oops, it's times 4. So you've only got the two on the same level, division and multiplication, then you just work left to right. And it's the same if you've only got addition and subtraction. You only work left to right. But that's only if you've got just those two. If you've got more than that, then you have to follow the rules of priority. Maybe I'll turn a few pages. Now, inequalities. You need to be able to work with inequalities this time. It's a little bit of a step up from working with equalities. There are rules that tell you how it works. That A is less than B, C is less than D. Then if you add the two, the answer is still going to be the less. So learn those, particularly that one there. Learn these, because you will need them, because as you advance in maths you need more and more things to be added in. Okay, here's a problem. Given that A is less than B and C is less than D, which of those statements is always true? So what you need to do is prove that the statement is true, or give an example to show that it's false. Okay, what about the first one? I'll just move on to the next page so I've got some space. So let's have a look at A minus C being less than B minus D, where you've got A is less than B and C is less than D. Okay, let's choose some numbers. I'm just going to choose randomly. A is equal to 4, C is equal to 2, and B equals 5, and D equals 4. Now just check. A is less than B. Yes, A is less than B, and C is less than D. So A minus C is 4 minus 2, and B minus D is 5 minus 4. Is 4 minus 2 less than 5 minus 4? And the answer is no, so it's false. So that one is false. The second one The second one, what could be a minus d? It was a minus d less than b minus c. And if we choose, say, a equals 6, b equals 8, c, these are just random numbers, 3 equals c equals 3, d equals 5, then 6 minus 5 is less than 8 minus 3. Yes, so it's true. What if I have the negatives of these ones? Well, the negatives of the a's and the c's, so c equals negative 3, d equals 5 maybe. Well, actually that was 5. Let's try that one. So negative 6 minus 5 is less than 8 minus negative 3. Yep, that works as well. So we're just going to prove them, and the same for c. Now 1 over b less than 1 over a, where a is less than b. Okay, so let's choose a equals 6 and b equals 8. Is this true? Is 1 over 8 less than 1 over 6? And the answer is yes. And it's so it's true for the positives. What if we have a equals negative 6 and b equals 8? So then 1 over b is 1 over 8, and 1 over a is 1 over negative 6. Is that true? No, it's not. So it's true for it's true for positive numbers of a and b, but it's not true for negative numbers. So just watch out about making assumptions for various things. A lot of you try and make up your own rules for things, and while I appreciate you trying, sometimes the rules aren't actually rules, they're not true. So sometimes that looks like it's a rule, but it doesn't necessarily work. We need to look at modulus, and I think I'm going to finish the video here and then start the next one shortly, because this is really, really important that you get this. It's a weird definition, but it has to be watertight. There's no point in just saying the absolute value of a number is, oh, get rid of the sign, and there's your answer. You need to have it watertight. So what this means is the absolute value of negative 3 is, now, there it is there. So it says if what's between the signs is negative, then the answer is the opposite of that. So what we've got between the signs is negative. So our answer is going to be the opposite of what we've got, which negative makes positive. So that's what you expect the answer to be, but that's the working that you're actually doing. So you need to know that. Now, absolute value of x minus 4.3 is 5.8. What that means is that the distance between the real number x and 4.3 is 5.8. So we're going to start with a number, 4.3, and the distance from there in either direction is 5.8. So 4.3 adding on 5.8 gives you 10.1, and going in the other direction gives you negative 1.3. So the answers there are just so easy from the number line. Put in your 4.3, and the distance then from either direction is 5.8. That's an important thing to know, just to remember that. Now I'm just going to stop this video here. I will start part 2 of this video on another video. So signing off.